13.4 is about compound probability. Problem 1 talks about, are the outcomes of each trial independent or dependent events? A lot of times, for what our purposes are, we're going to talk about whether each one of the events are independent of each other or if one depends on the other one happening. So in A, it says choose a number tile from 12 tiles, then spin a spinner. Are those independent or dependent events? Well, if you're just choosing a number tile and then spinning a spinner, they don't affect each other. So these are independent events. Okay, so those are independent events. In B, I pick one card from a set, then without replacing. So the key here is without replacing, I pick another card. Because I'm not replacing, it's dependent. If I replaced it, it would be an independent. Problem 2, they're talking about probability of A and B. If A and B are independent events, okay, so they don't affect one another. The probability of A and B is the probability of A times the probability of B. So the key word here is and. A desk drawer contains 5 red, 6 blue, and 3 black pens, 24 silver, and 16 white paper clips. What's the probability that you select a blue pen and a white paper clip? Okay, so I want the probability of a blue pen and a white paper clip. Okay, so what's the probability of a blue pen? Well, there's 6 blue pens out of 14 total. Okay, and there's 16 white paper clips out of 40 total. Punch in your calculator, multiply them out, you end up getting 6 over 35 when you reduce. Okay, 6 over 35 is the correct answer. That's approximately 0.171 or 17.1%. Again, all the same answers. In this one, we're talking about probability of mutually exclusive events. Okay, if A and B are mutually exclusive events, then A and B equals 0. Mutually exclusive events means they can't happen at any, there's no interlap or no overlap whatsoever. Okay, so again, the key word here is or, and what does or tell me? Probability of A plus probability of B. So athletes may only play one sport during a season. During a season. During fall, 28% play basketball, 24% swim. What is the probability that a randomly selected student athlete plays basketball or is on the swim team? Okay, so I'm just going to take 0.28. The key word here is or plus 0.24. 0.28 plus 0.24 is going to give me 0.52 or 52%. Now, what if they're not mutually exclusive? What if they overlap? So if they're overlapping events and you want to find the probability of A or B, you then take the probability of A plus the probability of B still. Again, the keyword's or, so I'm going to add, but you're going to subtract the overlap. So what's the probability of rolling either an even number or a multiple of 3 when rolling a standard number cubed? So I'm going to find the probability of even or multiple of 3. So again, the word's or, so we're going to add. So what's the probability of even? Well, there's 2, 4, and 6. So that's going to be 3 over 6, the probability of an even, or a multiple of 3. Well, how many multiples of 3 are there? There's 3, and there's 6, so there's 2. Well, I said 6 is both an even number and a multiple of 3, so I'm going to have to subtract 1/6. Okay? So that's going to give me 4 over 6, or a probability of 2/3.